So this video is going to teach us about rational exponents. So in our last class, or you watched the previous video, you recapped on our laws of exponents, and we're going to use those, but we're going to focus on rational exponents. So the first thing that we want to do is go back and think about, in Learning Target 1, what did we learn about the word rational, and what is a rational number? So Ms. Solomon, what did we learn about a rational number?
Rational numbers were whole numbers or fractions, and they can be positive or negative.
So we have whole numbers, we have fractions, and it includes positives and negatives. So we are going to look at simplifying expressions where our exponents could be whole numbers, they could be fractions, or they could be negative. So first, let's focus in on negative exponents, because we didn't look at negative exponents when we were looking at our laws of exponents. Our rule tells us if we have something raised to a negative power, like negative 1, a to the negative 1 is 1 over a to the first. And we're not going to get too deep into why this rule works, kind of like a to the 0. We didn't get too deep into why that one works. But to give you some ideas, when we raise a number to a positive exponent, we're talking about multiplication. Repeated multiplication is the wording we've used a lot. So when we raise something to the negative, positive and negative numbers are opposites of each other. Well, negative exponents do the opposite operation. We're talking about repeated division. So if we're considering it repeated division, 2 to the negative 1 tells me divide by 2 one time. Well, that's the same thing as 1/2. I'm dividing by 2 one time. 2 to the negative 2 is going to tell me divide by 2 twice, which is the same thing as 1 over 2 squared. So let's go ahead and try an example with the rule that we just learned. So if we had 3 to the negative 2, Ms. Solomon, what are you thinking we're going to do with that?
We're going to divide by 3 twice.
Divide.
So it's 1 over 3 times 3, which is the same as 1 over 3 squared. And since I know 3 squared, I'm just going to say that's 1 over 9.
Perfect. So we're starting to see that shortcut. When I see a negative exponent, we end up with that 1 over, which is what our rule said. Well, what if we had something like 1 over 3 to the negative 2? Now I'm starting with that negative exponent in the denominator already. Does that mean I don't need to move it? Well, let's see what ends up happening with the math. So, Ms. Alman, do we already know 3 to the negative 2?
Yes, it's 1 over 9.
3 to the negative 2 is something we already know. We know that this is 1 over 9. So there's my 1 over 9 that I replaced my 3 to the negative 2 with. So if we remember, do you have remember any rules about fraction divided by a fraction?
Yes, when we divide, it's the same as multiplying by the reciprocal.
So I can multiply by the reciprocal, which is 9 over 1. So this just gives me 9. So if we look at these two answers, when we had 3 to the negative 2 by itself, we ended up with 1 over 9. When we had 3 to the negative 2 in the denominator, we ended up with 9. So let's talk about what this is really telling us to do for a shortcut. So let's look at these answers that we got. When we had 3 to the negative 2, we ended up with 1 over 3 squared. And we can think of this as being 3 over 1. Just like we talked about, our whole numbers can be really written as fractions, so I'm going to put it over 1. And when I had 1 over 3 to the negative 2, I ended up with 3 squared over 1. Are you seeing any patterns, Miss Solomon?
Yes, it looks like wherever the negative exponent is, if it's in the numerator, I can bring it to the denominator, and the exponent becomes positive. If it's in the denominator, I can bring it to the numerator, and the exponent again becomes positive.
Perfect. So Learning Target 2 asks us to simplify expressions with rational exponents. So as you can see, our exponents in this example, they're whole numbers, but we have some positives and some negatives. So we do have rational exponents. And Ms. Solomon, what are your thoughts on starting to simplify?
Well, I do see that inside of the parentheses, the b has a negative exponent, so I could put that in the denominator. But I don't think that makes this problem simpler. I'm just going to use the rule we learned for raising a power to a power, and I'm going to multiply the exponents on the inside of the parentheses to the exponent on the outside of the parentheses.
Okay, multiply 4 times negative 2.
Yep, and that gives me negative 8.
And negative 3 times negative 2.
Which gives me positive 6.
Okay, now something we haven't talked about yet is we actually can't leave our answer with negative exponents, but we just learned how to simplify things with negative exponents. So how would you want to write this final answer?
I can just leave the b to the 6th on the top since that has a positive exponent. And then on the bottom in the denominator, I can say a to the positive 8.
Perfect. We learned that rule about moving things with negative exponents to the denominator if it's in the top, because we do not want no negative exponents in final answers.
That was
So if we look at this problem, we're not working with a problem with parentheses and an exponent on the outside anymore, but what we are working with is a giant fraction. And what we really need to keep in mind is that we have all of these rules for exponents, but we need to keep in mind that we're actually dividing these things. So the very first part of this problem I always tell students to look at is if there's coefficients, if there's numbers in front. Because we're not doing 4 minus 6 because we see a division bar. The 4 and the 6 here that I've circled are not exponents. So we're just going to do the operation it says to do, and we're going to do 4 divided by 6. And you can either use your calculator, or you can think about what's the greatest number they are both divisible by. So Ms. Solomon, can we think about simplifying the 4 over 6?
Yes, 2 can be divided into both of them. So we'd get a 2 on top and a 3 on the bottom.
So now that we have simplified the coefficients, now we can think about our rules for our exponents. So what are we seeing first that you would like to do, Ms. Solomon?
I think I'll take one letter at a time. So I'll look at the a's first.
Okay.
And the exponent of a in the numerator is a 4, and in the denominator it's 3. So I'm just going to subtract 4 minus 3 and get a to the first power, since that's positive, that just goes on the top.
Good. We ended up with a positive exponent, so like Ms. Solomon said, it's going to go on the top. So we have 2/3 with an a to the first on the top. And you can write a to the first, or you can just write it a. What do you want to go to next?
Next, I'll go to the b's, and this is going to be 6 minus 8, which is negative 2. So I have a choice. I can write b to the negative 2 right on the top, because those are the operations I did, or I could change it now and write.
So you don't want to do that?
Well, I could do that, or I think I could just change it now because I know the rule says if it's negative on the numerator, I can bring it to the denominator and make it positive.
Good. And now we have this c to the negative 3 in the denominator we need to take care of.
Yeah, that I'm just going to move to the numerator and make it c to the positive 3.
And do you see any more letters that we can combine? Like now can I take this A and this C, they're being multiplied, and add their exponents?
No, because they don't have the same bases.
Perfect. So this is our final answer.
The only other thing that I was thinking was, if I look at the problem, well, it looks like I have 4 A's on top and 3 A's on the bottom, so I can just get rid of the 3 A's on the bottom and leave the 1 A on the top. And then when I look at the B's, I can get rid of the 6 B's on the top and leave the 2 B's on the bottom. Sometimes I think maybe that's an easier way to look at it.
Yeah, let's look at it that way. So let's take a look at what Miss Solomon was suggesting might be an easier way to look at this problem. So I'm going to go ahead and simplify our coefficients. That should always be our first step. So we have 2a to the 4th, b to the 6th, over 3a to the 3rd, b to the 8. And I'm going to go ahead and move the c right now. I see a negative, I'm going to move it to the top. And we talked about how there's lots of different ways solving these problems. Maybe a tutor might show you a different way. So this isn't necessarily the only way, but we thought it might be an easier way to look at it. So if we think about what Miss Solomon was saying, we could actually expand the numerator. So what would the numerator expand to?
2, and then there's 4 A's, and then there's 6 B's.
And then should we expand the c's? Are there any c's that might cancel out in the denominator?
No, we're not going to do anything with that.
So I'm just going to leave that. And we know it's multiplication in between all of these b's and all of these a's. And then in our denominator,
3 A's and 8 B's.
it's a lot of b's for me to write.
So when I look at it this way, I can just cancel out 4 of the A's, 3 of the A's, sorry, and then 6 of the B's. So now on top, I have 2.
And it looks like we got one A left over. And C cubed left over. And what's left over in the denominator?
Just 3b to the 2nd power.
And is that the same answer we got before?
Yep.
So you can think about it as using our laws of exponents. We know when we divide, we subtract exponents. Or if it helps you, you can do like Miss Solomon did, where we had to think about, well, what is a to the 4th, and what is b to the 6th, and how many things can I cancel? That's really where we got our rules to begin with. And either way works for solving this problem.
Okay.
Now that we've looked at Learning Target 2 and simplifying expressions with rational exponents, I want you to go to my website and download Learning Target 2 homework and try the problems in here. If you're having trouble, look back in this video for help or call somebody over.